I'm happy to introduce Tina Wik, professor in architecture, who also have their own company. She's a member of ICOMOS and the Wood Committee of ICOMOS, the Scientific Wood Committee. So, Tina, welcome.
I can see it here. So thank you for inviting me here. I'm very pleased to be in Bodø and this region of Norway for the first time in my life. Can you hear me? Yeah, good. And I will present one of my own projects. It's one of my smallest projects. It's my own villa in the northern Stockholm archipelago. But I will give a brief introduction to what it's about. It started with a research project in University Dalarna, where I'm still working since more than 10 years back. And we made a study about different constructions. This is the CLT construction. We wanted to see whether a CLT construction, when you made joints with S-curves, like very tight joints, if you could get a very airtight building. And we also wanted to check the quality of different insulation materials. So what we did is we have half of the different of the walls towards different weather directions. We chose in normal mineral wool and wood-based insulation. And then we had sensors, and we checked them. They were constantly being monitored. And we also made airtightness checks, with certain intervals. And this is all, you can get all the results, the ones who are interested in this, from this website. We used Stora Enso's CLT components, and it was Serbof was financing it, and we were from University of Dalarna, me and my colleague, engineer Henrik Janoos, made the project, and one of the builders were HMB Constructions. And the interesting thing was that, and here you see the way we made them very, very airtight, all the connections. And we could see that the airtightness really resulted in reduced energy consumption. But we could also see that the conclusion is also that concerning insulation material, that the wood-based insulation has better performance than the mineral wool insulation, because the curves are much more equal. They don't get a risk for condensation, and you have very much slower difference in moisture and temperature change. But after 2 years, since this was just a test building, we call it Testkuben, we had to change its location after 2 years. So we had to change it from being in Borlänge, cities in Dalarna, to a location close to the university. And when changing it, we realized that, you see, we see one thing concerning the foundation, because since it was supposed to be a cheap building, we don't have that much money. Research money is always limited. And it was located temporarily on the site. We just put it on smashed shingle. And then we put insulation. The yellow is insulation. The one on the bottom is shingle. It's not concrete. And then we put the wooden board on top of that. And then when we lifted the whole construction, we realized that the wooden board, the bottom board, was completely dry. So it had not got any humidity, any kind of distortion or any effect from being, founded directly on the ground. So so what we did in the second location, we put sensors under the wooden slab, and we could realize that there was no humidity movement at all in this slab, though it was founded directly on the ground. So the foundation of shingles and 300 meters of insulation protected the humidity movement up into the wooden slab. So, and this was, of course, this is a much cheaper way of, and also much more CO2, better way, more sustainable way of founding buildings. So we wanted to find if there would be anybody who would be interested in doing a full-scale project. And we tried to get different municipalities with their new housing projects, because we knew that we had calculated you could find up to 2 stories buildings with this way of with this kind of foundation. But we did not find anybody willing to take the risk. So what I did in the end, I bought this site in the northern Swedish Stockholm archipelago, Roslagen, and decided to build my own house with this type of foundation. And also to make the same completely wooden house, reducing all plastics, all concrete, and so all the materials are sustainable and have a very low environmental impact. And this was based. So here's the house itself. The size of on the land is about 100 square meters, and we have it directed in the south-north direction, so we can put solar cells on it, and the view towards west is towards the sea, and it's. And we have the plan is, I will come further, the plan is 1 bedroom downstairs, 2 upstairs, and a loft, and then just a big living space. And of course, in the heart, we have the sauna overlooking the sea. And here you see, and also the solar cells that are here, and I will continue here to the. I will just mention one thing that we also, this is also built by CLT from Stora Enso, as we did in the research project, and some of them are also from the new factory in Sweden, so we received some of the test elements into this house. And also we have included a lot of building parts that were recycled. We have the staircase is one that was removed from Örebro Castle, where I designed it 20 years earlier, and now it was removed, so I got it, so I put it here, so the facade is partly designed due to this gift from them. And also lots of leftovers from my different projects are included into this building. And and here we see the same, the foundation, and it's founded on a rock, as you saw. So the rock is quite bumpy, so we could just fill it with gravel and shingles, and then pack it very hard, and it had to be really, really hard packed. And then you have the layers of insulation, and then the wooden slab on top. And of course, this was. We had to make all the installations on the foundation in the shingle and the gravel section. It had to be really exactly located, and so since it was a low-cost project, I made all the drawings, the structural drawings, the installation drawings, and we had to measure all those extremely clearly, and also the element drawings for the factory in Austria who made the elements. So it was also big, it was a bit risky to see how would it work when the elements finally came on site. And here's my husband working as well, so we did a lot of work ourselves. And in 4 corners, we made these kind of anchors for the house, so it wouldn't lift. And that's also where we dig in the anchors in the gravel. And then in the middle of the winter, the elements finally came in situ to the site, and you see we had this big crane, and that was a bit of a shock to see what's needed to have such a big crane on the building site, since we wanted everything to be so ecological, so sustainable, and then you have to have this equipment that really needs a lot of space, and you need to clean out a lot of space to have this equipment. So that was some kind of backlash. And then you see there's also the element for the stairs from the Örebro Castle that were supposed to be in place. But anyway, so it came like this, and here we kind of we're standing under, keeping these to fit into the holes of the bottom slab. and I could tell them that this element belongs there, and so it went rather quickly to mount the whole building. And here we started at 7 o'clock in the morning, 7th of January, and then it just went on. And I will not go through the whole building process, but the end was 2 o'clock at night, because we realized that there would be kind of wet snow coming at 4 o'clock in the morning. So we knew we had to finalize it, the whole thing, in one day, and then cover it with this covering. And then when the rain was over, we could make the ceiling, the roof, actually, because we had the elements were ready. Everything was done besides the exterior wooden boards. For the ceiling, we had not put this is the wood insulation called Schneider with tongue and groove connection, so it makes it really, really tight building. But they put the elements on site after the building was erected, and then we had electricians coming and installing all the electricity for the ceilings. Indoor ceilings, and drilling them in. Because this is also another issue when you work with CLT boards. You can't put all the insulations in gaps as you have in houses with joists. So you really have to plan everything very well in advance. I wanted to make this as an industrial building to reduce the transport costs, to put everything there when you ready-made. But it was very efficient and very good, but it demanded a lot of planning. It took me half a year to plan all those details. And as you see, here it was when it was fairly newly erected, and it's really, and we couldn't also control the builder really, how he, the one helping us with the foundation, and he kind of made this access road too low. So all of a sudden I got this house on a little bit high level, and I didn't want any banisters or rails around this terrace. So we are now struggling with building up the whole surface and the garden around. But another issue with even trying to avoid plastics in a building and build very sustainable, all the equipment came with plastic, in plastic. So we had you can't see it behind this photo, but the amount of plastic was almost as big as the building itself. So I think this is a crucial thing when you build and trying to do it sustainably. How can you avoid the packing industry, the disadvantage of the packing industry? How can you transport these pieces in a sustainable way? That's a problem to be thought about. And here you see then eventually we built the small storage house on the courtyard, and that storage house is built only from leftovers from this house and wood from the site. So we had only the glass, the plinths, and the roof surface that was bought. Otherwise, everything is actually from the site itself or from the building. And we have, as you see here, we have air heat pumps for the heating of the house. And that's a sea, and here also trying to get handle the raised level of the building without rails. And the facade towards south. And here I will also go into what we discussed earlier, the ventilation. This is we call förstärkt, it's a kind of förstärkt ventilation, frånluftsventilation, outgoing ventilation. And we have, this is now it's not ready yet, but here we have the fresh air coming in, and then it's going through a pipe like this and entering in the middle of the house. And you see the blue arrows; those are fresh air coming in. The red ones are outgoing air, and those are done with this kind of a device. And this is is a colleague from mine, a research colleague from University Dalarna, who is a Norwegian ventilation engineer who has started importing these from Belgium, and he calls his company Healthy Homes. And it's an outgoing air system, and you have the one up there takes the whole air from the whole building, and then in the corner I have connections to the shower rooms and sleeping rooms, and then and then it's evacuated out, and it's driven by sensors, and the sensors are kind of activated if the humidity becomes too high. So if there's nobody in the house, like with passive houses, you very often have problems with humidity because you don't have enough of airflow. So this kind of starts the ventilation if the humidity reaches over a certain level, and also if the temperature reaches above a certain level. And it's also there's this third sensor from the toilets. If the smell is bad, it also starts. And so it's just hidden in the toilet upstairs. And then you have fresh air also from under the stove. And here is and these are also reused marbles from other building project. And so here you have the sea, you enter, and it's a big room. And then also all these details that kind of ruin the impression, the character of the interior space, like doors and lots of, say, typical attributes like that you have. So I didn't want any modern doors. I didn't want old doors either. So I made my own doors of these same kind of CLT boards, but very thin. And I couldn't afford taking them to a carpenter to make proper locks. So they are just closed by very strong magnets. So you have to pull hard, and then you can open the door. And the whole interior is, as you see, that is the actual construction, and it's completely done. Nothing done with it. It's untreated, and some of the places are treated with. This is with egg oil paint, and the other one is. I have some walls painted with paint where the binder is from vegetable extracts. And here is the room. And, let's see, there. And this is the floor, the staircase from the Örebro Castle. And there you see up in the corner there, that's the whole outgoing air taken from the whole building, from the whole house. And it's very interior. It's very easy since it's just one big open space. And then also made some furniture inside from the same, the thin CLT boards like. And of course the sauna overlooking the sea, and the shower room. And here we have aspen wood, so typical. But what I would just want to say, what has this resulted in? It's always very difficult. I've been involved with wooden buildings since all my life, in my professional life. And I was also designing the first multi-story wooden buildings in Sweden. I've been designing the first, lots of first wooden experimental buildings of different types. And it's always difficult to be the first one, and especially difficult to be just talking about it. You have to realize a building before it started. Also, the multi-story wooden buildings are actually only now, 20 years later, starting to be built in a larger number. But so we were talking very much about this way of this kind of foundation for small-scale buildings. And we had one example in Gävle, we had one example, a friend of ours who built it, but then all of a sudden the owner of Fiskarheden Villa decided to try this way of making a foundation. So this is his own building in Borlänge, that he built, and this was Mondo Architects in Borlänge who made this design, and they chose the same, and this is also pine wood treated with silica treatment, both for the ceiling and the walls. And here you see also the same way of foundation, slightly different, but I had quite many seminars with the structural engineers before they decided on this. And of course he wanted to make also to show that he was very forward-looking, so the whole team of builders for his house were women. So they were built by a... and then, I'm not knowing my time, but here's my last slide, and I want to make a conclusion here that with comparison with 4 different buildings. And this is Strandparken in Stockholm, Sundbyberg, built by Gert Wingård. And this is built by Martinson's system. It's also a CLT system. And this is the test cube that we had for the research project, My Villa, and then the Villa Zero. And here we have what we say, these are our building code requirements, 90 square meter, kilowatt hours per square meter per year. And this is 90 is a normal building, 50 is a small passive building, and if you have a larger, it would be 20 to 50. And then there is a theoretical value, because you will have to give an energy balance evaluation when we get a building permit. So these are the ones that were made for these different buildings. And then these are the measured value after being in use. So we haven't got the values from Villa Zero. They are kind of a little bit secret, but we know from the other ones, and I can see that this way of building with very airtight, very controlled air inside in a house means that you get very less heat requirements. And what is interesting here is that, of course, that it saves energy. That's good. But it is, why should you put so much insulation in a building when you, what is, you really have to, why should you put more energy, insulation in a building than is required by the requirements if you don't want to, if you can't pay for the, depending on what kind of energy system you have, heating system you have in the house. So this is so we have realized that we are required to use more insulation than what is necessary, and which also means that the price of the building, the building cost, goes up. So we could reduce the building cost if there would be a better balance by the theoretical value and the measured value. So in this way we could get even more sustainable ecological buildings in the future. Thank you.